So this is a video from class 10th CBSE chapter 1, that is chemical reactions and equations, and this is the lecture 1 of it. So chemical reactions. What is a chemical reaction? So if I burn magnesium ribbon in the presence of oxygen, what happens? The ribbon burns and magnesium oxide is formed in the form of ash. So this change is a chemical change because this cannot be reversed easily. That means if I have to form again magnesium from magnesium oxide, it is not an easy process. So such a change which cannot be reversed is called chemical change. So whenever a chemical change occurs, we say chemical reaction has taken place. Okay. Another example is food gets digested in our body. Now food, what does food contain? Food contains carbohydrate, proteins and fats. When you digest this carbohydrate, proteins and fats gets converted to the simpler forms and they get absorbed by the blood. So can this change be reversed? Not possible. It is again an irreversible change, and this is again a chemical reaction happening there. There are many chemical reactions happening during digestion. Then again, another example is rusting of iron. You know, if you keep an iron rod for some time in moisture and in the presence of oxygen, the iron gets converted to rust. And what is rust, children? Rust is nothing else but a brown coating that is developed on the iron. And gradually, if you keep it for a long time, the entire rod gets converted to the brown form. So what is that brown form, or what is a rust? Rust is nothing else but hydrated ferric oxide. That means during rusting also, iron has reacted with oxygen and moisture to form rust. Is this a reversible change? No, it is not a reversible change. So again, there is a chemical reaction happening there. So chemical reaction is nothing else but a chemical change that occurs. Yeah. Okay. Now what is chemical equation then? Now this change that has occurred has to be symbolically represented. When you represent it with the symbols, that means what is happening in the reactants, what is happening in the products, and you represent it in the form of an equation, then you say this is called chemical equation. Now just now I gave you an example of magnesium. Here there's a picture given here. The burner magnesium ribbon he's holding a magnesium ribbon with a pair of tongs and heating it. So when you heat magnesium ribbon in the presence of oxygen, then it gets converted, gets burnt, and it gets converted to ashes. These ashes are getting collected in the watch glass. So magnesium has converted to magnesium oxide. So here you see the equation: magnesium burns in air with a dazzling flame. The flame color is dazzling, bright. Okay, and magnesium plus oxygen, magnesium oxide is formed. Okay, so this is a chemical equation representing the burning of magnesium. So chemical equation is nothing else but a symbolic expression by which you represent a chemical reaction. So chemical reaction can be expressed symbolically by using chemical equation, right? Now magnesium burns with oxygen, gives you magnesium oxide. Now we can also observe or recognize a chemical reaction by other ways. By either ways we can uh, recognize whether a chemical reaction has taken place or not, by the state, by color, by evolution of gas, or change in temperature. Something will happen when a chemical reaction takes place. Okay. Now, physical state of reactants and product. What are the physical states? Either the substances matter is solid, liquid, gas, or it is in the form of a solution. Okay, so if it is a gas, if it is a gas, it is represented by G. If it is a liquid, it is represented by L. If it is solid, it is represented by S. And if it is aqueous means when it is dissolved in water to prepare a solution, it is represented in the form of AQ. So whether the reactant is in which state, if that is mentioned in a chemical reaction, in a chemical equation, then it becomes more informative. Okay, so the chemical reaction becomes more informative if the physical state of the substances of the reactants and products is mentioned. So calcium oxide, if it is a solid, we write S in bracket near the reactant, and if it is if another reactant is a liquid, H2O, you write L in bracket. put an arrow which shows the which separates the reactants and products, and then calcium hydroxide is formed, which is aqueous. Aqueous means something dissolved in water is called aqueous. Clear? So calcium hydroxide aqueous is formed. So when I am writing the states, this reaction becomes more informative. Okay, another example, if I take Fe, Fe is iron, it is in the solid state, reacted with copper sulfate, which is an aqueous solution, that means prepared by dissolving copper sulfate solid in water. Okay, it gives you ferrous sulfate again, which is an aqueous solution, plus copper, which is a solid. Okay, so this is again a chemical reaction, and representing the states makes it more informative. Then methane gas, methane bracket it is gas is written G, 2 plus 2 oxygen gas gives you carbon dioxide gas plus water gas. So here again we are mentioning the physical states of the reactants and products and making the reaction more informative. Clear? Okay. Balancing equation. Now what is balancing equation? When I am writing a chemical reaction, the reactant side, the product side, the number of atoms of each element on the reactants and product side should be same. So that is called a balanced equation. So we balance the chemical equation so that the number of atoms of each element involved in the reaction remains the same at the reactant and product side. Okay, let's say the reaction Fe plus H2O gives you Fe3O4 plus H2. So which atoms we are having on the left hand side? Fe, H and O. On the right hand side Fe, O and H2. So but the number of atoms are not same on both the sides. So we require to balance this equation. So for that, first we will make a table in which we will list the elements. We will write the number of atoms in reactant side, number of atoms on the product side, check how many they are, and then we'll one by one balance each atom. So iron is number of atoms in the reactant, iron is 1. In the product side it is 3. Hydrogen is 2 on the reactant side, product side it is 2. Oxygen is 1 on the reactant side and 4 on the product side. Okay. Now let's start balancing one by one. So atom of iron on reactant is 1 but product it is 3, so not balanced. Hydrogen is 2 each. But let's see how it goes. Oxygen is 1 on the reactant side and 4 on the product side. Okay. Now atoms of oxygen. One by one we'll go on balancing. So atoms of oxygen. Initially in reactant it is 1 in the form of H2O. Okay. And in the product it is 4 in the form of Fe3O4. But they require to be the same number. So this is 4 and this is 1. How do I make 1 and 4? When I multiply it with 4. So 1 is in water. So that means the water requires to be multiplied with 4. So my equation now becomes Fe plus 4H2O gives you Fe3O4 plus H2. Now on the reactant side, hydrogen has become 8. But on the product side, it is 2. Let's balance hydrogen now. Let's see how it goes. So atoms of hydrogen initially in the reactant side, it is 8 as we saw in the previous equation. And in the product side, it is 2. So how do I balance it? In reactants, it is 8, but in the products, it is 2. So we'll multiply the hydrogen with 4. So it becomes 8. So Fe plus 4H2O gives you Fe3O4 plus 4H2. Clear? Now let's see iron. Iron initially atom in the left hand side is iron in the reactant is 1, but iron in the product is 3. So we have to multiply this reactant with 3 to make it equal. So 3 iron plus 4H2O gives you Fe3O4 plus 4H2. So my reaction becomes 3Fe plus 4H2O gives you Fe3O4 plus 4H2. Clear? So my reaction is balanced now. Let's check another reaction. Zinc plus H2SO4 gives you zinc sulfate plus H2. Okay. So which atoms are there? Which elements are there here? Zinc, hydrogen, sulfur, oxygen. So we'll list the elements. Now let's see number of atoms in the reactant side. Zinc is 1, hydrogen is 2, sulfur is 1, oxygen is 4. Product side, zinc is 1, hydrogen is 2, sulfur is 1 and oxygen is 4. So 1, 2, 1, 4, 1, 2, 1, 4. That means this reaction is already balanced. There is no balancing required. Okay. Okay, clear? Okay. Now let's see the types of chemical reactions. The reaction in which two or more substances react to form one substance is called combination reaction. So combination reaction is the first type of reaction. Here, for example, calcium oxide plus water gives you calcium hydroxide. So the two substances, calcium oxide and water, have reacted to form calcium hydroxide. This is called slake lime, and the calcium oxide is quicklime. So quicklime is changed into slake lime. Okay. Another example is burning of coal. Coal burns, carbon plus oxygen gives you carbon dioxide. Again, here two substances are forming one substance. So it is called again a combination reaction. Then formation of water. H2 reacts with O2 to form water. Again, this is a combination reaction. Okay. So when a solution of slake lime produced by in the above reaction is reacted with carbon dioxide, calcium carbonate is formed. And this calcium carbonate is used for whitewashing, giving shiny finish to the walls. Okay. And it is interesting to note the formula of calcium carbonate uh, is calcium carbonate, which is the same formula as of marble. So calcium hydroxide plus carbon dioxide gives you calcium carbonate plus water. So slake lime is used for whitewashing the walls. Clear? Okay. So here you see in a beaker, calcium water is taken and calcium oxide is added to it, and you see here that it is getting dissolved and slake lime is formed, and this slake lime is nothing else but calcium hydroxide. Yeah. Now decomposition reaction. What is decomposition reaction? When one substance gives you many substances. So when a single substance decomposes to give you two or more substances, you call the reaction as decomposition reaction. Decomposition reactions are of three types: thermal decomposition, photolytic decomposition, and electrolytic decomposition. So in thermal decomposition, what happens? Only the substance is taken in the test tube and heated. So when you heat ferrous sulfate, for example, what is formed? Fe2O3, sulfur dioxide and sulfur dioxide. So the green color ferrous sulfate changes to the reddish brown color ferric oxide, and the gases are released in the form of sulfur dioxide and sulfur trioxide. Okay. Then calcium carbonate, when it is heated, calcium carbonate is one substance. It forms calcium oxide plus carbon dioxide. So calcium oxide is formed plus carbon dioxide gas is given out. This is again a thermal decomposition because on heating the reaction occurs. Then lead nitrate. When you heat lead nitrate, lead oxide is formed. Then nitrogen dioxide is formed and oxygen is formed. So one substance is forming many substances. So white color lead nitrate gets decomposed to brown color lead oxide, and the brown color gases are given out. Clear? So this is called thermal decomposition because the decomposition is carried out by heating. One substance is forming many substances or heating. So when you take a boiling tube, add ferrous sulfate to it, dye boiling tube and add ferrous sulfate and heat it. So ferrous sulfate is a green color powder. On heating, it converts to ferric oxide, which is a brown color, and sulfur dioxide and sulfur dioxide gases are given out. Okay. Then calcium carbonate, similarly, if you take in a test tube and heat it strongly, then you get calcium oxide and carbon dioxide. Calcium carbonate is called limestone, which converts to quicklime, that is calcium oxide, and the gas given out is carbon dioxide gas. Clear? Then lead nitrate, if you heat, then PbO is formed, NO2 and O2 gases are given out. So when you heat lead nitrate, you get lead oxide and nitrogen dioxide and oxygen are gases given out. Okay, so all these reactions are decomposition reaction wherein one substance is forming many substances on heating. So what kind of decomposition reaction is this? Thermal decomposition reaction. Then photolytic decomposition. When a reaction is carried out, decomposition reaction is carried out by sunlight, then or any light, then it is called photolytic decomposition. So when silver chloride is kept in sunlight, it converts to grey color. Silver chloride powder is white color, but when you keep it in sunlight, it becomes grey color. So silver is formed plus chlorine gas is given out. Okay. Similarly, when silver bromide, if you keep it in sunlight, it converts to silver and bromine gas is given out. So this silver is a gray color. So the white color powder or yellow color powder gets converted to gray color. Okay, this decomposition is happening in the presence of light. So you call it as photolytic decomposition. Okay, these above two reactions are used in white and black photography. So it is used basically in the photography. Clear? Okay. So here you see silver chloride powder is kept in china dish. In sunlight, presence of sunlight, it converts to silver. A grey color powder is formed plus chlorine. And if you keep silver bromide, then silver is formed and bromine gas is given out. Clear? So this is called which decomposition? Photolytic decomposition, which is happening in the presence of light. Electrolytic decomposition. So when decomposition happens on passing electric current. So in a container you take a solution. Let's take water for example and pass electricity in it. So anode, cathode, two rods are dipped here in the test tubes, in which inside oxygen is released, other side hydrogen is released. So on cathode hydrogen is released, on anode oxygen is released. Anode and cathode are the two different plates connected to the positive and negative terminals. Okay, so H2O on passing electric current gives you hydrogen gas and oxygen gas. So this is called electrolytic decomposition. Okay, then next type of reaction is displacement reaction. The chemical reaction in which one element displaces the other element. One element takes the place of other element. So when you react iron with copper sulfate is a solution and iron is a metal. Then what will happen? Iron sulfate and copper is formed. That means iron has displaced copper from its salt solution and taking the place of copper. It is formed FeSO4 plus copper is given out. Okay. So this is called displacement reaction. So more reactive metal displaces the less reactive metal. Okay, clear? So here you see one activity. Take 3 iron nails, clean them by rubbing with sandpaper. Take 2 test tubes marked as A and B. In each test tube, take 10 ml of copper sulfate solution. The 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube B for 20 minutes. Keep one iron nail aside for comparison. After 20 minutes, take out the iron nails from the copper sulfate solution and compare the intensity of the blue color of the copper sulfate in A and B. Also compare the color of the nails dipped in the copper sulfate. So basically what happens here, iron nails are dipped in copper sulfate solution. So what should happen? FeSO plus Cu is formed. So FeSO4 is a green color solution that is formed. So blue color changes to a green color and the copper is formed which gets deposited on the iron nails. So basically that is happening. And if you compare the color of the nail with the nail that is kept aside, you may note the great difference. Clear? So this is displacement reaction that has taken place. So basically the nail becomes brown in color because blue color of copper sulfate solution fades away and nail becomes brown in color. Why it becomes brown in color? Because it gets a coating of copper. So zinc plus copper sulfate gives you zinc sulfate plus copper. Another example. So instead of iron, if you take zinc and add it copper sulfate solution, zinc sulfate in copper is formed. So zinc takes the place of copper from its salt solution and copper is displaced. Okay. Now if you take lead and add copper chloride, you get lead chloride and copper. So here again, the lead has taken the place of copper, lead chloride is formed and copper is displaced. So zinc and lead are more reactive than copper. So they displace copper from its salt solution. Is this clear? So this reaction is called displacement reaction. So zinc plus copper sulfate gives you zinc sulfate plus copper. Lead plus copper chloride gives you lead chloride plus copper. Displacement reaction. In this reaction, two different atoms or group of atoms are mutually exchanged. Okay. So here when sodium sulfate reacts with barium chloride, it gives you barium sulfate plus NaCl. So Na2SO4 plus BaCl2 gives you BaSO4 and NaCl. So both the atoms are mutually exchanged. So a white color substance, barium sulfate, is formed in this reaction. So this insoluble substance is called precipitate, and this reaction is also called precipitation reaction. The reaction in which precipitate is formed is called precipitation reaction. So here you see the two atoms and groups of atoms are displaced, are taking their positions are changed. So precipitation reaction, any reaction that produces a precipitate, is called precipitation reaction. So lead nitrate plus Ki gives you lead iodide plus KNO3. So PbNO3 whole twice lead nitrate plus Ki potassium iodide gives you lead iodide plus potassium nitrate. So again, this is also a displacement reaction, double displacement reaction, and also called a precipitation reaction. Clear? So double displacement reaction, just now we saw sodium sulfate plus barium chloride gives you barium sulfate plus NaCl. So here sodium insoluble substance is formed, which is known as precipitate. So barium sulfate, a downward arrow represents the precipitate, and any reaction that produces a precipitate is called precipitation reaction. So this double displacement reaction is also called precipitation reaction. Clear? Then reduction. What is reduction? The loss of oxygen or gain of hydrogen is called reduction. The reaction in which there is loss of oxygen or gain of hydrogen, it is called reduction reaction. And what is redox reaction? Redox reaction is a reaction in which the oxidation and reduction, they both happen simultaneously. For example, here copper oxide plus hydrogen gives you copper plus H2O. So copper oxide is changing to copper. That means there is a removal of oxygen. So this is a reduction reaction. H2 is changing to H2O. That means there is addition of oxygen. So it is an oxidation reaction. So reaction in which oxygen is removed is reduction. Where the oxygen is added is hydrogen, is oxidation. So zinc oxide plus carbon gives you zinc and carbon monoxide. So zinc oxide is changing to zinc, reduction. Carbon is changing to carbon monoxide, it is oxidation. So because here reduction and oxidation are happening simultaneously, so this is called a redox reaction. Now manganese dioxide plus HCl gives you manganese chloride plus H2O plus chlorine. When there is an increase in charge, that is also called oxidation. When there is a decrease of charge, it is called reduction. So when MnO2 is changing to MnCl2, there is a decrease in charge. This is Mn is plus 4, here it is Mn plus 2. So this is reduction reaction. But HCl is changing to chlorine. Chlorine is having a minus 1 charge, it is changing to 0 charge. So minus 1 to 0 is an increase. So this is oxidation reaction. So MnO2 changing to MnCl2 is a reduction reaction. HCl to Cl2 is a oxidation reaction, and both are happening simultaneously. Therefore, it is a redox reaction. Clear? So how do you identify oxidation reaction? By loss of gain of oxygen, loss of hydrogen, and increase of charge. How do you identify a reduction reaction? Loss of oxygen, gain of hydrogen, or decrease of charge, decrease of positive charge. Clear? So oxidation is what? Oxidation is gain of oxygen or loss of hydrogen. Copper plus oxygen gives you copper oxide. It is what type of reaction? Oxidation. Okay. When copper is heated, a black color substance is formed. If this copper oxide is reacted with hydrogen gas, then what happens? It changes to copper and water is formed. So copper oxide plus H2 gives you copper plus H2, and this is a redox reaction. In this, copper is losing oxygen and hydrogen is gaining oxygen. So hydrogen is getting oxidized, copper oxide is getting reduced. What is reduction? Reduction is, as we said, loss of oxygen or gain of hydrogen. And when both happen simultaneously, then you call it as redox reaction. Okay. Then in the above example, copper oxide is getting reduced. It is also called oxidizing agent. The substance gets reduced is also called oxidizing agent in the redox reaction. And hydrogen is getting oxidized, so it is called reducing agent in the redox reaction. Here, so getting oxides bringing about reduction, getting reduced bringing about oxidation. Clear? So is the chapter clear? Okay. Now what is exothermic reaction? The reaction in which heat is given out, heat is released along with the products, then it is called exothermic reaction. Methane plus oxygen gives you carbon dioxide plus water. Okay. Then respiration is also an exothermic reaction. Decomposition of vegetable matter into compost is also an exothermic reaction. In all these reactions, heat is given out. Okay. The endothermic reaction, the reaction in which heat is absorbed, which require energy to happen, are called endothermic reaction. So barium hydroxide plus ammonium chloride gives you barium chloride plus ammonium hydroxide. This is an endothermic reaction. So exothermic reaction when the heat is given out, heat is released. Endothermic reaction when heat is required or heat is absorbed. Clear? Okay. Now have you observed in the daily life, metal is attacked by the substances or moisture, acid. It gets corroded. Now silver, which is grey in color, it becomes black, it gets a black coating. Then copper, which is brown in color, gets a green coating. What are these coatings? That means these metals react with the moisture and oxygen and they get corroded. They change into the oxides and hydroxides and carbonates. So corrosion causes a damage to the substance. So if it is a corrosion of car, it damages car bodies, it damages bridges, it damages iron nailings, it damages ships, and it brings damage to all the objects made up of metal. Now when fats and oils are oxidized, they become rancid and their smell and taste changes. So usually the substances which prevent oxidation, they are called antioxidants. When they are added to foods containing fats and oil, they are kept in airtight containers to slow down oxidation. So the fats and oils, they get oxidized, they become rancid, their taste changes. Okay, so to avoid this, antioxidants are used. They are stored in tight containers. Okay, now that means corrosion is what? When metal is attacked by substances around it, such as moisture, acids, they are they get corroded. Like you see the reddish brown covering coating on iron, rust is an example of corrosion. Then black coating on silver, green coating on copper. This is all the examples of corrosion. Then rancidity, when fats and oils are oxidized, they become rancid. Their smell and taste changes. Okay. Then antioxidants are added to foods containing fats and oils. Okay. Okay. Thank you.